Welcome guys, I am Yogesh from Professional Training Institute. Today we will see, today may be the last class on digital electronics. Yeah, we will see multiplexer, demultiplexer, encoder, decoder and all remaining terms. What all is pending in digital? Can you open the syllabus? So in last class we had done gates, digital gates, AND gate, OR gate, and through transistor. You done those questions? Subsection. You done that? Any doubt? Okay. Yeah. Open. No. Open and check if anything remaining that I have to cover. Today we will cover multiplexer, demultiplexer, encoder, decoder, shift register. Apart from that, anything is pending, that you let me know.
So if you search in encoder, many techniques are using. So
Yeah.
every topic they are using many techniques.
Yes. So whatever we are doing, that is like just show me syllabus. Okay. Yeah, so we done number system, we done binary addition, subsection, 2's complement, we done the interconversion of number system, we did logic gate, and today we will do all other things. Yeah, flip-flop is there, which I not mentioned. Okay, so what we done is, we had seen yesterday the gates, and we seen the AND gate, OR gate, NOR gate. So take AND gate. What is this? This is flip-flop. Okay. What is flip-flop? Storing. We discussed this thing earlier? No? I think we discussed in the electronics when we calculated number of transistors. You calculated number of transistors in pen drive? Yes or no? Number of transistors in pen drive? No? Okay. It is in your class, not in this class. We will cover it up. No problem. So what is this? Flip-flop. What is the use of this? It store the bit. It store one bit. It store one bit. Okay, so if I have to store one byte, then how many flip-flop I needed? Why? So I need 8 flip-flop. I need 8 flip-flop to store 1 byte. Okay. To store 1 byte, how many flip-flop I needed? 8 flip-flop. Okay. Fine. So how this AND gate is built, or how we can make with the old OR gate also. We can make with the exclusive, or we can any gates we can use here to make the flip-flop. Although few are having advantage, few are having disadvantage. Normally flip-flop is made with the NAND gate, normally. But it does not mean that we cannot make with any other gate. We can make with any other gates. Okay. So that how many transistor is needed to make this gate? At least 2. Okay, so one fine day we had seen one of the logic like this. So when we give 0 0, when we give 0 0, 0 1, 1 0, 1 1, what we was getting? When we give 0 0, what we will get? See, this is the problem. If you don't want to learn, nobody in the world can help you. One full day we spent in that, 2 hour class. then also we are in position where 1 and 0 is coming. Shame on you people. After spending full day, you are answering like that. Yeah, tell me what will come. 0 or 1, right? Good, tell. Yes. I am taking output here. Which 5 volt. Okay, so answer is 1 1 1 0. See, when you don't know it's fine, but when we discussed, full day we spent on that, we did nothing on that day. Then also you are like that, how, what to do in that case? Fine. So, yeah, at least 2 transistors I need to make 1 gate. So, for making 1 flip-flop, how many transistors I needed? 4. At least 4 transistors I needed to make 1 flip-flop. To store 1 byte, how many transistors I needed to store 1 byte? 32 transistors, very good. So I need at least 32 transistors to save 1 byte. Any doubt in this? Very good. Now consider I am having a 16 GB pen drive. I was having today, I not brought. So I showed to them. Really I am having 16 GB pen drive. So consider this is 16 GB pen drive. How many transistors it will have? Can you tell me? How many transistors it will have? 16 GB pen drive. So number of transistor. How you will do? What you will do? See, I will help you. You can help me 16 GB into 1024. This much? What is this? This one is MB. Into 1024. What is this? This is GB, 16 is GB. When we multiply 1024, it becomes MB. Again we multiply 1024, KB. Again we multiply 1024. It becomes bytes. And each byte having this many transistors. Understand? Just multiply quickly. So this is the minimum number of transistors. When we make flip-flop, we need 2-3 more gates. Do it, calculate quickly. Done? Mobile, bring it. How much? Tell me full number, no? 549 755 81 813. One more 8 is needed. 813 triple 8. Wow. This many transistors in this pen drive. Feel more or less? More. But this is less only. Because when we talk about i7, had you seen i7 processor? How big it is? No. It is not more than this big. This big only. i7 processor. And you can imagine like how many transistors it will get. i7, i5, yeah.
When they are manufacturing this, that how it will be the hardware, what are the technology they are using?
Yes, very good question. It come out from your curiosity. I really appreciate. See how that chip is manufactured is they are also writing the program. They are also writing program like we write in C language, they write in VHDL or other language they write program. That is also simple program. Do this, copy this, move this, like that they are writing program. I don't know exactly, but they write program, simple computer program. That computer program they build, compile, and when we write program, our output is hex file. When we write, our output is hex file, and this hex file we download into the microcontroller. Had you seen microcontroller? Okay. All our board, whichever I have shown, they are all having microcontrollers. So our output is this hex file which we download into microcontroller. Their output is some different kind of files. That file they can use to give to some machine, and that machine fabricate all those transistors or those components in the VLSI level. Ask question. Did I answer your question?
Hardware they are into this much of they using this much of transistor for manufacturing for one country.
Yes. How? That is what I said, that VLSI they use, very large scale integration. VLSI means very large scale. Means maybe like 1 mm square will having a 1 lakh or 10 lakh transistor. That is the definition of VLSI. We say, right, VLSI, I want to work in VLSI or VLSI technology. We say like this, right? So that VLSI itself says like this, like 1 mm square. This is bigger than, it seems to be 2 mm square actually. You understand? Whatever I drawn here, this is 2 mm square. It means divide 4 part of that. This can be 1 mm square. So this much of area is capable to hold maybe 10,000 transistors.
We cannot do it.
We can.
These are some. So, by random we cannot do it. That's why there is some.
Very high-end machines, very costly softwares. Very costly softwares are used for this purpose.
So some products are they making second quality. How they are making second quality? In particular, high quality product means they have specification, sir. But same thing, how they can second code or second quality.
What do you mean by second quality?
Sir, duplicate quality.
Okay. It's not.
In some product will become easily duplicate quality, second quality.
See, the main I cannot give you direct answer. We are live, but I will tell in another way. See how we can duplicate the thing is like we can change the functionality what some IC is doing, and we can try to read. We can try to make same thing, same software, which can produce similar type of result. So that is one criteria. Another criteria is there are some tools available which is they are able to detect the full IC itself, what is inside that IC. And if you break the IC, did you break IC? Did you broke any IC? No. We will try to arrange some IC. You broke and see that. Inside you won't get nothing. You will not get anything. You break and see. You will see some black, nothing actually. We are not able to see any transistor or nothing internally. So, but there is some method which we can read it. I don't know much on that. So you asked like how to build. So there are dedicated software and dedicated process are there. Through that they have made it. So in a small pen drive also we are having this kind of processor. Consider we are having 4 GB RAM or maybe Intel processor. All processor is made up with similar kind of thing. Processor is nothing but a flip-flops. 90% cases. 90% cases it will be flip-flops. Okay, fine. So that is what the flip-flop is, and that is what the number is in the 16 GB pen drive. Then we are having 500 GB, 1 terabyte hard disk. 1 terabyte you can amazing, right? You can 1024. So this will become, this will become 1 terabyte.
So if we have 16 GB pen drive means, if we go and see properties means there's some GB will be lost.
Lost. It's not loss actually. It's that to operate. See what is memory is. Memory is a raw unit. Okay. Consider this is a memory, and inside this I am able to keep something. You understand? Any doubt in this? This is memory. I am able to keep something inside it, but I need some place to make this boundary also. You understand? If this boundary is not there, where I will save? So I need some memory to make this also, so that I can save the other things inside it. Making sense? So those some memory is lost, that is not lost. There is already we saved some program. So that program is responsible for pen drive behavior. That is mainly the file and the file read write operation, basically driver of the pen drive, which when you connect Toshiba pen drive, your computer show Toshiba pen drive. Although it comes from USB enumeration, you know enumeration. When you connect any USB device, it goes through the enumeration process. What is the enumeration process is, both device exchange some data. Hey, hi, I am Yogesh. You will say, hi, I am Manu. So this is the enumeration process initially. And this enumeration process, PC understand the thing. PC know, oh, okay, he is Manu. Hi Manu, how are you? I am fine. Yeah, take this movie or give me a movie. Like that. What was your question? I missed.
Sir, if 16 GB pen drive is
yes, so where those memory goes? Yeah, so those memory goes into this kind of. See, if it is a only raw memory, how he will say I am Manu? He is to store somewhere, right? He is Manu kind of thing. If he is a complete lost like kids they don't have any memory. So how he can say I am Manu? Slowly mother and father put feed you are Manu, you are Manu, you are Manu. That's why he is able to say I am Manu. So for that we already reserved some memory. It's not like memory lost, it's used.
So sometimes I think that the company will cheat or cheat.
No, it's not nothing like cheat. We are using like that.
Because they say it's a 16 GB, but we go in some things.
No. I'll tell you what is meaning of that 16 GB. See, normally in digital world, when this 24, in digital world this 24 is used. In normal cases we use 1000. Okay. So when you multiply 24, consider it is coming 16 GB. But if you divide by 1000, it will become something else. I'll tell you. So you divide by 1000, this, again 1000, again 1000. So this will become kilo, this will become MB, this will become GB. You can say this much. Something wrong in there, either in your calculation or some understanding. But maybe your 16 GB, when you see in a 1000 mode, that it will come different. Of course, right? This is more, this is less. 1 kilo, when we say 1 kg, we know 1000 grams. But if I say 1 kg is 1024. So this 24 is keep incrementing number of bytes. So in digital world, you will have more, in digital world GB will be less. But they may say you in terms of normal terminology. Making sense what I am saying? It's nothing like cheating, it's just understanding. Normally this happens when we buy hard disks. Yes? Where you face this problem?
Sir, I got 8 GB pendrive, sir, before that 1 month. But in properties I go and see it will come 6.78 GB. So,
Which company?
Sony.
So they all are a standard company. I don't think anything like that is possible.
Most of the
Even America itself like that.
Yeah, so few memory I needed to save somewhere. That is not a cheating. That is help us to make work pen drive. Of course, what they can say, 16 GB pen drive, 14 GB you can use. They may say like this. 16 GB pen drive, 14 GB you can use. So it is marketing techniques. So that's why they are saying 16 GB. Actually, I also getting 14.5 something. So making sense? That's why in order to overcome this problem, now the international organization is set up a new rule, and then for all digital world we are using GBI. So this GB is different than our normal GB. Okay, gigabyte is different and gigabyte height is different. So this new terminology will help us distinguish these two problems. Okay, fine. So hope you understand. So many transistors are there in a small pen drive. Okay. So for this class I told, like we are around the transistors. Millions of in this room itself we will have millions of transistors. All our phone, all processors, all camera, keyboard, everybody is having this thing, transistors. So we are around the transistors. Making sense? Fine. Let's move multiplexer. What is multiplexer? Mux. You studied?
many inputs
Many input.
to one single output.
So means many input, one output. And what is demux is? One input, many output. Can you tell example? Where we can in practical life?
So TV channel, TV cable.
Yes, TV cable is one of the example where we are getting all signal over one line and then we can, but at a time we are getting one output.
So only we can saw the particular channel. So any input, one output.
Okay, so no, many input, one output, it is at the TV station. Then this cable came to my home. So one input, many output. At a time how many output? One output or many output? Simultaneously. One. Okay. So TV channel is a good example, perfect example for that. Multiplex. Any other example? Wi-Fi. Wi-Fi is all can connect, right? Simultaneously.
One source, we can connect demux.
No. This is not that one, right? One example for demultiplexer, then TV channel cannot be example. Any one example is possible.
TV channel is for mux. Multiplex. Not for demux.
No, this is on the TV station. This is on TV station, not at my home. This is at my home. Chitra, sleeping?
Sure.
Any input?
Demux means if we give 3 inputs, then we get 8 outputs. Suppose. So 3 into 8 demux.
Okay.
3 input means we will get simultaneously 8 outputs.
Simultaneously.
Yes, sir.
What you say?
Sir, it has some selection lines.
Okay. That is what she said. 3. 3 is selection line. You not studied. So what is multiplexer?
Multiplexer has two inputs and you get single output.
Single output. And demultiplexer?
Single
Single input,
input,
many output.
complex by
No, that is fine. So Wi-Fi is an example of multiplexer, yes or no?
no.
Why?
It's a signal and everyone can access. Too many devices can access the Wi-Fi signal.
Okay. So TV channel is an example of demux or not?
Single cable
Hmm.
and we can randomly select a channel.
Mm-hmm.
TV cable for multiplexers, sir. That's in cable so many channels there. It is many input. In TV we are choosing only one channel. That is of course.
Yeah, if you see from that angle is fine. I am seeing from the
Both.
I am seeing the cable input. This is my TV.
In one cable so many channels there, sir. So many frequencies.
Yeah, so that is the example of demultiplexer, right?
So TV is both multiplexing and demultiplexing examples, sir.
Yeah, okay, very good.
So particularly demultiplexer, the Wi-Fi is example, sir.
Hmm?
Wi-Fi, particularly demultiplexer, the Wi-Fi is example.
How? That is what I am saying, like what is the output you are expecting in demultiplexer? How many output at a time you are expecting?
Wi-Fi modem we connect only one line cable, sir.
No sir, what I am saying, how much output you are expecting in demultiplexer at a time? At a time, how many output you are expecting in demultiplexer? At a time.
More than input.
How it's possible? Consider it is demultiplexer and it is a consider 4 output. How many control line I needed? 2 control line. 4 output. 0, 1, 2, 3. Okay. What I can give here? This is 2 input. What I can give here? 0, 0, 0, 1, 1, 0, 1, 1. Okay. Consider I give him 0, 1 here. What it will select? He will select this line. So how many lines he select at a time? 1. Okay. How Wi-Fi can be example? In Wi-Fi simultaneously you all are connected with the Wi-Fi.
An example, customer from telephone.
No, first finish this. So this TV line where I am receiving the TV signal and it is having so many channels and I am able to watch whichever channel I want. One channel at a time. Is this an example of multiplexer, demultiplexer, or yes or no? Yes. Okay. What is confusing here? Wi-Fi, you cannot say like, although Wi-Fi is doing multiplexing inside, I am not talking at that, I am talking system level. Okay. If we go too much deep, then maybe answer will change. As a general user, not as an engineer, as a general user, through Wi-Fi you all are connected. So it's, of course he is getting one input, but he is giving to all, okay, take it. You understand? That is different example, that is not fit here. We need it is having one input, but that one input contains many things. Many thing or one thing I don't care, but whatever I select, I should get that. If I want to see GTV, it should show me GTV. I don't know whether how many signals are coming, GTV, Star TV, BTV, MTV, CTV, GTV. I don't know how many signals he is receiving or not receiving. I don't care. You understand? How many signal he is receiving, not receiving, I don't mind. But whenever I select 0, 1, I want this channel to be played. And when I select 1, 0, I want this channel has to play. Making sense? What he is receiving, I don't care. After my selection, is he receiving? I don't care. Making sense? So this is an example of demultiplexer. And here we are having a selection line. Through selection line we can use. Okay. If we have to make any embedded product around multiplexer and demultiplexer, what should be that embedded product? Means, I am not asking any technical thing. I am asking non-technical thing, where I am asking like where we can use mux and demux. What kind of application in embedded products? Don't say Wi-Fi router to me. Okay.
In some circuits we will use like LCD output and some frequency output and some 4 outputs we are using. At that time we can use demux.
Okay.
So that 4 are input, and when we want particular LCD, then we can on that.
Yeah, possible. Had you used like that earlier sometime?
Yes,
Office telephone networks.
Okay. No, I want answer like that, but that is also not right answer because she not thought. She is using some database. It's okay, but not up to the mark. Okay, how? Yeah, go on.
Party games will be there.
Uh-huh. Call me after some time. 2 hours. Yeah. Yeah, voting machine can be example. Voting machine is not using mux. Actually, it is simple switches. Nothing much inside that. Voting machine is pretty simple. Some other time you ask me, I tell how internal it works. Simple switches, nothing mux deep. But that can be an example. What she said. We are having a 3-4. Consider we are having a one is frequency, one is voltage, one is current, one is time, and here is the selection line. And this output, this is LCD. This may not be LCD. This goes to some microcontroller. And some of the line from microcontroller goes to LCD. So this line is tie up here, this line is tie up here, and this two line goes to here. Okay, so what I did, this is mux, this is demux. Okay. Consider I want to display frequency on the LCD. What I will do from microcontroller, I will send 0 signal. So that 0 will appear here also and here also. This 0 will select this line here. And this 0 will select this line here. So he come to know frequency is selected. And he will display the frequency. Of course, there is some method should be there through which I am getting the frequency. Means I need some sensor or something which will give me frequency. Whoever give me frequency, that I will display. Same other time, if you want to display voltage, so we will give 0, 1 here, 0, 1 here, 0, 1 here. This voltage will come here to here. Okay, that time this channel will break and this will connect to here. This will break and it will connect to here. Making sense? And it will come here in microcontroller. And in the microcontroller, he will, of course, he will reach from somewhere voltage and that he will. Making sense? See, you people should have mastery in this kind of thing. Okay, so don't select what I am going to say now. You should people should have mastery over this kind of thing. So if any project come, you should able to make block diagram. This is called block diagram. Okay. So nothing to remember here. I am not asking resistor, capacitor, transistor. No. It is just the use of the thing. What is use of this? Writing. What is use of this? Sitting. What is use of this? Reading. Making sense? So if I ask you, okay, make the block diagram for photocopy machine. You should not say photocopy machine. You say, okay, photocopy machine. Start making block diagram. Making sense? This will help you. I am sure this will help you. 100% it will help you. And how it will come? When we have more session on that presentation, then you will have many things it will open. Many things it will understand. Okay, no issue. So fine, this is mux, demux. Many time in practical application, while we are making hardware, we have to use mux, demux. Yeah. What is decoder? What is encoder? Sorry? No, I don't know what is encoder. So help me to understand.
Encoder means convert information into code form. Any file format into code form.
Okay, Chetra. Not studied. I'm not asking definition. Say something.
Decoder, there are three types. Priority encoder,
Okay. Light encoder. But what encoder do? I'm not asking definition.
So basically,
So it is convert analog to digital.
Analog to digital.
Signal into
No. That power is only God is having.
So
ADC.
signal, analog signal to digital signal.
ADC. Only ADC can do that magic.
signal into coded form.
Signal into coded form. What type of signal it take input?
Both analog or digital.
Analog also? Okay, I don't know. We'll talk digital. So consider I want to say message 101. Okay. So how I will say 101? Okay. What it do in 101 actually? Consider it saving 8 lines. And all line is having a relay. All are having relay and all are having bulb and ground. All are having relay, this all are relay, and this is LED or you can say bulb. Okay. Now I want to turn on this LED or this bulb, or you can say in my home here I am having a 8 switches, which is there 8 switches, and I want to turn on switches. Particular switch, I want to turn off this light. What I have to do?
Say graph particular serial number.
Yes, it will have some number. Then
That should be fair. I say.
that should be.
Fair as it. If you want to.
Talk properly. Say confidently. Wrong also we should say confidently.
If you want to on the third switch, we should send 0, 1, 1, right?
Okay. Yes. Correct. So if we want to turn on third switch, then we will send 0, 1, 1. So that particular switch will be turned on. Why? Because this is going to be on. This is going to be on that time. Making sense? So it will, what basically it is doing, I send him some code word and he is decoding in all line. This can be example of Wi-Fi. Because everyone is having a signal, everyone phone, every one of you is having Wi-Fi signal available for you people. You understand? But at a time, the Wi-Fi signal is multiplexed. Multiplexed means at a time you will use, again you will use, It's like that. Wi-Fi signal is not okay for you. Okay, so how this can be example of Wi-Fi? Manu, how this can be example of Wi-Fi? Can you come here and explain the decoder one time to me? Yeah. So what is decoder, how it works, and how Wi-Fi can be a example for that? Yeah, you address to class, not to me.
Encoder means it's converting signal into coded form. But in decoder is reverse form of encoder means it's convert code into signal form. Decoder used in communication system.
Listen him ask question if any doubt. Yeah,
How
go
will
on.
you convert like waves?
Wait for a signal. In mobile communication.
Now, how many output it will be?
One output, sir.
One output.
And what ways? Like
Then what is difference between multiplexer and decoder? What can you make multiplexer?
This 4:1 multiplexer. Much. This 4:1 much.
It may have selection line also.
Two selections. Yes, one is.
So this 4 line is not in our control actually. Our control only selection line we are having in control. You know this thing?
Selection means select the line.
Yeah, selection. We are having only control of selection line. We are not having control over the input lines. You know this thing? Because in that my block diagram also I have connected only selection lines. Okay, so how many output I am getting in multiplexer? In multiplexer,
Multiplexer. One output.
one output. And how many output I am getting in decoder?
Decoder also one, sir.
What is difference between this?
Here is converting code into signal form, sir. Here what is given input, that is output. It does not convert any signal output.
What do you mean by that? How it converting signal? What is it? It converting signal.
Convert code into signal.
How? What signal? Means consider I given 0, 0, 0. What I will get out?
This is example communication system voice. In encoder, voice is converted into code form. In research set, its code is converted into signal form. Mobile communication system.
Anybody else want to attend decoder? Yeah. Yeah. Explain. Then why you not ask that time?
Simply using
Who is going to explain? I want to see. I'll not waste my energy.
Sir, they have
Go there and explain. Otherwise, go and explain multiplexer.
in multiplexer we having many inputs and only one output. The output is depends on selection line. By controlling selection line, we can choose the output. How it is using, how it is selecting is, if we want to select this input, then it will, by using this selection line, we can select this input only. That is if we want to select this line, we have to given selection line input is 0, 0, then it will select this line. If we want to select 1, it will be 0, 1.
What is example of multiplexer?
Sir, multiplexer is LCD screen that she told already. That is signal generator. There is
Make the block diagram for she says.
In microcontroller I am giving input which is an higher cell. If I am giving 0 0 and it denoted, if I want to select voltage, it
What
is
will happen when I give 0 0?
the selection I give to the demultiplexer and it will goes to the marks also selection line. It is 0 0 for voltage and 0 1 for current and 1 0 for frequency and it will select voltage. Fine. And this voltage will go to marks. Fine.
Very good. Very good. Yeah, what doubt you have in decoder?
So actually says this encodes the binary value in a signal, sir. If we want to change the binary to any form of signal, we have to use in this decoder itself. We have to use DAC, digital to analog. We show that this analog signal, any signal. This are by zeros and ones, sir, digital format.
Yeah, Chetra, you go and explain decoder. No, but why you people are not asking? Go, you explain decoder.
It's the same load of animation connection. The input is a digital format, the output will come in analog format.
Who said analog?
I mean digital format, sir.
See, that is the problem. You people are sleeping here. You are wasting time. Neither you are waiting, neither you are reading at home, nor you are paying attention here. Why you are wasting time? You can do something else also, right? Save your time. This is your life. Don't waste your life. Encoder, signal, analog to digital converter. Signal, what is signal? Don't know. Signal. Use come in, say truck na. Say encoder give me output as a truck. Why you are not saying truck? No sir, it will not give truck. But it giving signal na. Signal also truck. There is no difference between truck and signal. Because signal you know it is somehow related with that. That's why you are saying signal. But it is not at all related with the whatever we are talking. See, you don't know, fine, but you are sitting here, then it's your responsibility to learn. When I am asking, then you have thousands of doubts. It's not like something new. I already told you, go and study. You study one page of internet and then you say, it's saying some example of wise encoder. And then you close and went with your friend. Go with them only, na? Why you are wasting time? See, you are getting multiple methods to learn. You are not encasing any of them. Okay, what is decoder is? If we are having a 3 input, what all possible combination in this 3 input? 0 0 0. Okay, like that many means 8 possible combination is there. And output here is not 1, here is output is 8 lines. Okay. And what I did last time, I connected relay here. Nobody is asking relay is what? One output coming after decoder.
That's why when I started asking, so that's why after that
When I put relay here, after that I put bulb here, and then I said, if I want to turn on third switch, I will give 0 1 1. That time, and not at all able to tell anything. It's not like you are a scientist kind of thing. Understand yourself? Okay. Just to turn on, just to show you this.
Sir, for switching purpose.
Just a switching purpose. Yeah, what is doubt you said when I asked? I will again, I am going to call every one of you here. Ask any question. I am calling everyone again. I will sit there.
Sir, it's not computing, not
Nothing, it's just a relay kind of. Whatever you select, based on that one output will go.
So this is a waveform like it.
Nothing waveform. What waveform? No waveform. It will just select one line. That's all. Whatever input you will give. No signal. What is signal? If this one you want to say signal, you say signal. I don't mind. But you should know what is meaning of signal. Otherwise, say truck to this. I don't mind. Yes, you go for 4 into 16 decoder.
Giving the same binary.
Yes. See, if you see the word encoder means we are encoding something. Yeah, so she understand what I said. Do not understand. She, you understand. It may be Chinese. It looks like Chinese. I've been in China for some time. So, maybe it looks like Chinese, but it's encoding between us.
So every output having relay.
No, sir. This relay is just for your understanding. This is decoder. This is decoder, not out. You want to put relay, you put it. If you don't want, don't put it. I am calling everyone here. Ask question. I will, whatever I say, I do. Any question?
When asked question of
Decoder is also same. If we are having a similar kind of decoder, this is encoder. So when we will have similar kind of decoder, consider when this line is high, I will get output of 0, 1, 2, 3. So I will get 0, 1. Same multiplexer, demultiplexer, same thing. Encoder, decoder is also same.
so that's decoder.
That's the encoder. Yeah, that's a decoder. Yes, sorry. This is decoder. I'm sorry. That is encoder. This is decoder. That is encoder.
Encoder, so we have to give depending upon
So how do we use that?
8 means
Sorry. Yes.
encoder. So how we will come to this figure? Like if you want to 3 as output, what we have to do?
We will make it high. This one. All other will be 0. So only one I will get like this. You understand the importance of this is, consider you are having 100 line here, 100 lines. So output you will get 7 line. You will get only 7 line output, 5, 6, 7. So 100 line and here 7 line. Consider 100 students are sitting here, or say 100 students are sitting. Say one time, 100 students sitting. Yeah, very good. Healing and peace.
So in 100 they give only one input to the high value.
Yeah, I am telling. So 100 students are sitting and anyone raising hand, anyone, not more than one. Anyone is raising hand. So I will come to know which number of student is raising hand.
So how can we find a particular number, sir?
Here I will get number. No, whoever is raising hand, I will get number 10001111. 8 bit. Manu, I am calling. Yeah. If you put bulb, it will. But how this bulb will be? Yes. What do you want to put? Bulb will be what? This is decoder. This is encoder.
What is the encoder for decoder?
Sorry.
Input of decoder.
Input of the decoder is number of lines. As many as lines possible.
Lines means
Lines means digital lines. You can say digital input, either 0 or 1. Only 2%. In digital, what we are reading digital. Electronics is already over. Only zeros and 1 is possible here. But at a time one will say raise hand.
Sir, if you get 0, 1, 1, I have to give input to the third group only.
Yes, very good. But this is 100 lines, na? So maximum 128 line is possible. Why 128? Yes, very good. I thought you are out of sync. Why 7? Octal value. No, I said 128. What is that? 128. What is 7? She said 7. It's octal value or what? 111 is 7. Very good. See, I said 128. Then she said 7 and I said very good. Can anybody tell the relation between this? Yeah, what is 2 to the power 7?
2 power n means input.
Eh?
And means input.
2 power n.
Say confidently, even if you say wrong, should have courage to say wrong.
2 power n means input, number of input.
Yes, so how many input are here?
Number of input.
How many? In this example, what I said, how many? 100 I said. But there is still 28 more is possible. So how many input possible here? 128. Why? How many output line I will get? If I am having 128 input, how many this side lines I will get? 7 lines. Okay, why 7? Eh? 128 input. So why 7 line I will get here?
2 power 7. 2 power n.
You say na, he is saying wrong 90% cases. You say. And he is not going to share his salary. You have to earn your own salary. Hmm? 2 power 7 into 128 equal to. So that 7 is not this 7. No, I know what you are thinking, but you improve your level. So that 7 and this 7 is different. Don't try to make me fool, because I am alive all the time when I am in class. Whatever I say, I am taking responsibility for that. And I know what you are saying, what is this 7 and what is that 7. Yes, Manu, I am calling you. So any doubt you have before, I am calling everyone basically. Any doubt you people have, encoder, decoder?
Encoder how it convert input to output. This processing technology.
Okay, see what is the thing is, we are having, this is actually complete digital design. I don't want to go earlier before your question into that. But what is the input here is, I could say I0, I1, 2, 3, 4, 5, 6, 7. And I will not take 7, I will take 4, otherwise it will be very long. So consider it is I2 and I3. This is my input. What all possible input is here? 1, 0, 0, 0, 0, 0. Very good. Any other combination? Very good. I really happy. Because you are not saying 1, 1 and 1, 1 and 1, 1 and 4, 1. I am really very happy. And output? How many lines of output I am expecting?
2.
So what output I will expecting here?
0, 0, 0.
0, 0.
1, 0.
No, wait. I should not say 0 here. I should not say 0. So in this case, only I want output in this line. Only one output I
I
need.
not will get.
This will be one in while this input.
I not will get, sir. I not that line will get output. I not line will get output.
One means I not is type 2, type 1.
I not, I2, I3 the output.
Okay, yeah. So I not output here I will get 1, here I will get 0. No, what I am expecting in this case, when one line is high, then I am expecting here I should get 0, 0, right? I should get, so both lines should be 0 when this is high. But when this line is high, I am expecting 0, 1, 1, 0, 1, 1. Correct? Any doubt in this?
Sir, how?
When this line is high, I am expecting both output lines should be high. See, consider, I will make this 4 lines, 2 output. Consider this is high. What output I am expecting? 1, 1. That is what I return. When this line is high, I am expecting 1, 1. When this line is high, I am expecting 0, 0. Means both lines should go 0. Making sense?
Sir, there also 1, 1.
Where?
Sir,
Here? We should say 1, 1. No, but we need 0, output 0 that time. When this line is high, we need output 0. We don't want 1. Making sense?
for output only we want to make 0, 0.
Yes, because we have to, here at this end, I don't know what is happening there, but here I should come to know which line is selected there. Or consider you people are raising hand. Anyone, 4 of you raise hand. Anyone can raise hand. How do I come to know? So you have to tell, Chetra will help me. Chetra, you come here. So she is the intelligent device which I put in between. So any one of you raise hand and you tell me into this format. Okay, yeah.
0, 1.
0, 1. Okay. So that is what I came to know. I came to know 0, 1 is raising hand. You understand? And raise the 0, 0 hand one time for, yeah,
0,
0, 0. See? I came to know. Making sense? Okay. So I am designing this device here. When any one of you, when 0, 0 person is raising hand, then I need 0, 0 output. That's why I wrote 0, 0 here. Making sense? Okay, yeah. Take your seat. So now I have to write this equation. So output O0 is equal to I0, I1 naught, I2 naught, I3 naught. No. This is 0 plus, no, I should not write for 0, I should write for 1. So in the 1, I0 is 0, this is 1 plus for this. So I0 naught, I1 naught, I2 naught, and I3. So this is the equation for O0. Same way I will write for O1. O1 is, this is the equation. So I0 naught, I1 naught, I2 and I3 naught plus I0 naught, I1 naught, I2 naught and I3. So this is equation for O0, this is equation for O1.
So why are you using I1, I0?
They are input. Based on the input, see how you come again. See, she should have some method to tell me whether it's 0, 0 or 1, 1. So what I did is, I wrote something here. She also don't have eyes. So I wrote something here. Okay. So now this all fingers are connected to you people. This finger. All 4 fingers. She don't have eyes. Understand? She don't have eyes. This 4 finger is connected to you. And she is having this formula which I wrote in her mind or her head. Okay. So now when you raise any one hand, consider 0, 0 person is raising hand. Okay. So she is connected all hand. So 0, 0 person is raising hand. So I3 is 0. Yes or no? I3 is 0. So in inversion of I3, oh you are I0. So you are raising hand, right? So when you raise hand it means 1. Okay? Inversion of 1 means 0. Same way means it will calculate. Okay, this is the digital design. I don't want to take much. You do the some practice on that. We can discuss in detail. Okay, so that's clear. So this is the inputs. This is the output. Make the equation. Do the some sorting. You may need to review one time. Discuss with me if any problem is there.
We go to output 0 first. Second, this after this.
This one?
First one.
This one. Here we are having 2 times 1. 2 times 1 we are having, here we are having 2 times 1. In all other condition it will automatically give 0. If we are having this input, okay, if this line is going high, he will give 0, he will also give 0. See, this is 1. Okay, this is 1. That's why I wrote only 2 elements here. Here, this is 1, this is 1. That's why I wrote 2 elements for this. Okay, for any input, consider this is the input. Understand what I mean? Consider this is the input 1. Okay, let's calculate O0. O0. Let's calculate O0 when this input is high. It means I0 is high. So I0 is high means inversion of I0. What will be? 0. With 0 if you multiply anything it will be 0. Here also same thing. Yes or no? Yes, sir. So what is the output O0? 0. So we got 0. Any doubt in this? Let's calculate O1. O1 is, this is 1, right? So inversion of 1. So this term goes, this term. So you got 0 both. Now he is raising hand. He is raising hand. It means I1 raising hand. Consider here. You are 0. Inversion of you. So this is 1. You are making 1. So this is already 1. You are 0. Inversion of u is 1. You are 0. Inversion of u is 1. What you got here? And this will go 0. Oh sorry. This term goes 0.
Again it will come 1.
No. Because this I1 naught is there. You see? I1 naught. You are high, right? Inversion of u goes 0. So this term is going 0. So only 1 we will get only one time. So next time we got 0. Next time we got 1 0. Making sense? Ask question. Manu.
Yes, sir. 0 1 also it become 1. 1 0 1 second.
Here.
Second.
Second. Yes.
Then also it become 1.
How?
Because we have that value is 1.
Which value 1?
I,
What about I2? Is 0 or 1?
so 1.
You are raising hand or he is raising hand? If he is raising hand, then again we have to calculate. Yes, Manu. You have to, I am erasing, you have to remake again. If you have any doubt, ask me. Any question? This is last time I am asking.
Output 0 equals to I0 dash, I1, I2 dash and I3 dash.
Sorry?
Output 0 equals I0 dash, I1, I2 dash, I3 dash.
How?
How to write this?
How to? How to write this? Okay. How to write this? This is 1. We have to see where in output 0 where we are having 1. So we are having 1 in this place. So we have to come here. This is 0. Yeah. So make it I dash. I not dash. This is 1. Write as it is I1. This is 0. Write inversion. This is 0. Write inversion.
So I not only become inversion, must invert to 0.
Come on. No, say it.
So in inversion only change the number.
Change the number for zeros.
Zeros.
You know why? Because we want 1 output. We want 1 output. That's why we are writing like this.
If I want from C is 1, sir. So I have to choose 0 0 1, sir. I want 0.
You want 0?
Right,
Ask question. No? Not understand means ask question. You have to ask question. See, when you work in company, you cannot say, I not understand, you just give me salary. I don't understand anything. Give me salary. If you not give salary in first, I will go on hunger strike. Give me salary, but I don't understand. You ask what you not understand.
So if she is, say her input is 1. Sir, whether I consider it as 0 or 1, sir, that time.
What is your value?
Mine, I'm 0.
Yeah, so it will consider 0 only.
Sir, that input is 1. I know is equal to only 1. Others are I know that.
Yes, that is what we decided, right? That's why I said thank you to you today. Because only one input is high, all other are 0. Here the next input is high, here next input is high, here next input is high. You have to come here, I am calling. Any question ask. Don't say I am not understand. I am erasing, nothing will be here on the board. Done? Any question? No? Say something, I am erasing otherwise.
Sir, sir, why we add these?
These two.
Sir.
Because we need 2 output there. This also we need 2 output. So we need either this output or this output. That's why we are adding. Here also 2 output. So we are adding. Yeah, that is output 0 and output 1. this is 1 na? In output 0 where this 2 place we are getting 1. That's why we wrote this. 0 output automatically comes 0. We don't need to write anything for that. This 0 will automatically go 0.
All are 0 only. All are 0 only.
Yeah, all are 0 means you consider this input. Only your I0 is 1 here. I0 is 1. I0 is 1. So inversion of I0?
0.
0. So this term goes, right? Here also same. In this term also goes. So 0 will automatically come. Only we have to write for 1. Okay, done? Anything? No question? Okay, come Manu and Chaitra. Quickly. You people do in your notebook. Design same thing in half the thing. Same thing.
Same.
Yeah. Thanks for watching, guys. I am leaving now. So, but still the things are going on. Okay, bye. See you again.